LeQ Audio welcomes you. Process Control Block PCB in Operating System. Hello everyone. Welcome to this detailed audio lesson on Process Control Block, commonly known as PCB in operating systems. In this session, we will study what a process control block is, why PCB is needed in an operating system, the structure and components of PCB, how PCB works during process execution, PCB's role in process scheduling, context switching, and multitasking, PCB from exam and interview perspective. PCB is one of the most important core topics in operating system. Questions from PCB appear in BCA and MCA University exams, GATE and other competitive exams, technical interviews. So let us begin from the fundamentals. What is a process? Before understanding PCB, we must clearly understand what a process is. A process is a program in execution. For example, opening a browser, playing a song, running a compiler. Each of these is a process. A program stored on disk is inactive, but when it is loaded into memory and starts execution, it becomes a process. Need for process information. In a multi-programming system, many processes exist at the same time. CPU switches rapidly between processes. Each process has its own state, priority, and resources. The operating system must always know which process is running, which process is waiting, which process is ready, where each process stopped execution. To manage all this, the operating system uses a special data structure called Process Control Block. Definition of PCB. Simple definition. A process control block is a data structure used by the operating system to store all information related to a process. Technical definition. A process control block is a kernel-level data structure that represents a process, stores its execution state, maintains all information required to manage and control the process. Why PCB is called the identity of a process. PCB is often called the identity card of a process because every process has exactly one PCB. Without PCB, a process cannot exist. All details of a process are stored only in PCB. If PCB is deleted, the process is destroyed. Location of PCB. PCB is stored in main memory, RAM, inside the kernel space. This ensures security, fast access, protection from user programs. When is PCB created and deleted? Creation of PCB. PCB is created when a new process is created. Example, when a user runs a program. Deletion of PCB. PCB is deleted when the process completes execution or the process is terminated. Structure of process control block. Now let us study the internal structure of PCB, which is extremely important for exams. A PCB contains multiple fields. 1. Process identification information. This section identifies the process uniquely. Process ID, PID, a unique number assigned to each process, used by the operating system to distinguish processes. Example, process A, PID equals 101, process B, PID equals 102. Parent process ID stores the ID of the parent process, helps maintain process hierarchy. 2. Process state information. This field stores the current state of the process. Common process states are new, ready, running, waiting, terminated. The OS updates this field continuously. 3. Program counter. The program counter stores the address of the next instruction to be executed. Why is this important? Because when CPU switches between processes, the OS must know where to resume execution. 4. CPU registers information. This part stores the contents of general purpose registers, stack pointer, accumulator, index registers. Before a context switch, CPU register values are saved in PCB. After resumption, values are restored from PCB. 5. CPU scheduling information. This field is used by the CPU scheduler. It includes process priority, scheduling queue pointers, time limits. Scheduling algorithms rely heavily on this information. 6. Memory management information. This field stores base address, limit address, page table pointer, segment table pointer. It tells the operating system which part of memory belongs to the process. 7. I/O status information. This section contains list of I/O devices allocated, list of open files, I/O request status. It helps OS manage device sharing. 8. Accounting information. Used mainly for monitoring and billing. It includes CPU time used, execution time, user ID, job or process number. Important for multi-user systems. PCB and process states. Whenever a process changes its state, the OS updates the PCB. Example: running to waiting, ready to running. PCB always reflects the current condition of the process. PCB and context switching. What is context switching? Context switching is the process of saving the state of the current process, loading the state of the next process. Role of PCB in context switching. During a context switch, CPU registers are saved into the current process PCB. Program counter is updated. PCB of the next process is loaded. CPU resumes execution. Without PCB, context switching is impossible. PCB and multitasking. Multitasking works because each process has its own PCB. The OS switches rapidly between PCBs. This creates the illusion of parallel execution. PCB and process scheduling. The scheduler uses PCB to decide which process to run next, which process should wait, which process should be terminated. Scheduling queues are basically collections of PCBs. PCB versus process table. The process table is a collection of all PCBs in the system. Each entry in the process table equals one PCB. PCB and threads advanced. In multi-threaded systems, each process has one PCB. Each thread has a thread control block. PCB stores information common to all threads. Advantages of PCB: efficient process management, fast context switching, accurate scheduling, better resource utilization. Limitations of PCB: PCB consumes memory. Large number of processes equals large process table. Context switching overhead. PCB from exam and interview perspective. Very common questions. Define PCB. Draw PCB structure. Role of PCB in context switching. Difference between PCB and process. Fields of PCB. Real-world analogy. PCB is like a student file in a university. Name equals process ID, class equals process state, subjects equals memory and CPU info, attendance equals CPU usage. Without the file, the student cannot be tracked. Final conclusion. The process control block is the backbone of process management, essential for multitasking, critical for scheduling and context switching.